this video, we are going to learn how to find mean or max of a quadratic function. As you already know, f of x of the form ax squared plus bx plus c, where a, b, and c are real numbers and a is a non-zero number, is general form of a quadratic function. Now, orientation of a quadratic function depends on the sign of a. A is called the leading coefficient. So if a is positive and if a is negative, the orientation will change. If a is positive, it will be a function which bends upwards. If a is negative, it's a function bending downwards. Now, if it bends upwards, in the case a is positive, the vertex of the function will be the minimum point of the function, and in the case a is negative, the vertex will be max. In both cases, these graphs are called parabola. So these two functions are called parabola. Now, our aim here is to find the coordinate of these vertices. I mean, whether it bends upwards or downwards. So mean or max, we are going to find the coordinate of the vertex. Now, at first I rewrite f of x plus, which is ax squared plus bx plus c, in completed square form. So I write it again, ax squared plus bx plus c. Next step is to factor coefficient of x squared. So it will be x squared plus b over ax. I leave some space here plus c. Next step was to add and subtract a square of half of coefficient of x. Coefficient of x is b over a times 1 over 2, which is half, will be b over 2a. So b over 2a. A squared is added and the same thing is subtracted to keep it the same. Now, it will become f of x is equal to a. So these three terms together make an identity. So it will be x plus b over 2a to the power of 2 minus b squared over 4a squared plus c. Now I multiply a, it will be a x plus b over 2a squared minus a, and a simplifies to b squared over 4a plus c. Now I take common denominator there, it will be a x plus b over 2a plus I multiply by 4a, multiply by 4a, so it will be 4a as common denominator, so minus b squared plus 4ac. Now, here we learn that if a is positive, we will have a point of minimum as the vertex, and if a is positive, we will have is negative, it will be the maximum as the vertex. So if a is positive, it is a square here. If a is positive, you are looking for the minimum value. You are looking for the minimum value. So it is a positive function. So, and you are going to make it as least as possible, So we know that as it is a square, it will be always greater or equal to 0. So positive times a non-negative number will be a non-negative number. So it will increase overall the expression, but we are looking for the minimum. So I want to stop this function from increasing. So the only thing I can do is to choose the least possible value for this expression, which is 0, because it is a non-negative number. So I put x plus b over 2a is equal to 0. So x will be minus b over 2a. Now it is x coordinate of, here in this case, minimum. To find y coordinate, I replace this into the equation, so it gives you this value. Now let's go for the case in which it is negative. So if it is negative, so your vertex will be maximum. So you want to find the greatest possible value for this expression. So this is negative, and this function is always non-negative. Negative times a non-negative number will be always negative value, but we want to find the maximum value, so we should stop this expression. How? By making it 0. So again, x plus b over 2a will be 0, so x is minus b over 2a, the root of this expression. Then, so in both cases, having mean, having max, in order to find x coordinate of minimum or maximum, it's enough to just put this expression, the completed part, equal to 0, the root of this bracket equal to 0. So when you put it equal to 0, it gives you x coordinate. To find y coordinate, you can easily replace in the equation. So now let's go for an example. Let me open a new page here. Now find coordinate of the vertex of f of x is equal to 2x squared plus 6x minus 2. So first step is to rewrite it in the completed square form. So it will be 2x squared plus 3x minus 2 is put aside. Next step is to add and subtract half of coefficient of square of half of coefficient of x. 3 over 2 is added, then subtracted. These three are making identity, so it will be f of x is equal to 2x plus 3 over 2 squared minus 9 over 4 plus 2. Then I multiply by 2, so it will be 2x plus 3 over 2 squared minus 2 times 9 over 4, 2 to simplify. 4 simplifies to 2, then it will be 9 over 2 plus 2. Then f of x will be equal to 2x plus 3 over 2 squared. So giving denominator of finding common denominator, it will be 4 minus 9, which is negative 5 over 2. Now it's written in the completed square form. Now this function a has a leading coefficient of 2, which is positive, so it bends upwards. So the vertex is a minimum. So to find minimum, this expression is increasing the whole expression. So I want to stop it. So how? By making it 0. X plus 3 over 2 is equal to 0. So x is equal to minus 3 over 2. It is x coordinate. To find y coordinate, put it in the equation. It will be 2 minus 3 over 2 plus 3 over 2 to the power of 2 minus 5 over 2. This will be 0. So y will be minus 5 over 2. So the coordinate of the minimum point is actually r minus 3 over 2 and minus 5 over 2. Now let's see another example in which the function has a maximum as their vertex. Now again find the coordinate of vertex of f of x is equal to negative x squared plus 4x minus 1. Now, first step again is to write in the completed square form. So f of x will be equal to minus x squared plus 4x minus 1 is put aside. Next step is to factor coefficient of x squared, which is negative. So it will be x squared minus 4x, leave some space, minus 1. Now, here I add a square of half of coefficient of x and subtract the same thing. So it will be f of x is equal to minus x minus 4 over 2 will be 2, so it will be minus 2 a squared minus 4 over 2 will be 2 to the power of 2, 4. It is positive times negative, negative, so minus 4 minus 1. Distributing this negative, it will be minus x minus 2 a squared minus 4 times negative will be positive 4 minus 1 will be 3. Now it is written in the completed square form. Now as you see here, leading coefficient is negative 1, so it bends downwards. So as it bends downwards, so the vertex is a maximum because a is a negative number. So this function has maximum value. To find the maximum value, I should, stop this expression because it is decreasing our expression because it's negative times positive, overall negative. So I put this expression equal to 0. X minus 2 is equal to 0, giving you an answer of 2. So to find y coordinate, I replace it 2 minus 2 squared times negative 0 plus 3. So y coordinate will be here 3. So the coordinate of maximum will be 2 and 3. I hope you all understood what has been taught in this video. Thanks for watching this video. Have a nice time.